Hello student, good morning. How are you? I hope you are fine. Welcome to online class. Today we are going to discuss about to construct and prove De Morgan's theorem. Aim of this experiment is to construct De Morgan's theorem to prove De Morgan's theorem. List of equipment required for this experiment is DC regulated power supply 0 to 30 volt 1 ampere, breadboard single strand hookup wire, wire cutter and stripper, etc. List of electronic component with specification. Component required for this experiment is IC. The number of IC is IC7432. Specification of this IC is quad 2 input OR gate 14 pin deep dual in line package TTL IC transistor logic integrated circuit. Quantity required is 1. The another IC required is IC7408. The specification of this IC is quad 2 input AND gate 14 pin deep TTL. Quantity required is 1. The another IC required is IC7404 deep 14 pin hex inverter TTL IC. Quantity required is 1. The next IC is IC7400. The specification of this IC is quad 2 input NAND gate 14 pin deep TTL IC. Quantity required is 1. The another IC is IC7402. Quad 2 input NOR gate 14 pin deep TTL IC. Quantity required is 1. The another component required for this experiment is resistor 330 ohm quarter watt carbon composition fixed resistor. Quantity required is 1. The another component is LED means light emitting diode. Red color 5 mm. I max is equal to 36 milliampere. Quantity required is 1. The pin configuration of IC 7408 means IC 7408 AND gate IC. This IC consists of 4 AND gate. This IC is 14 pin IC. Pin number 7 is ground. Pin number 14 is supply pin. Pin number 1, 2 is input. Pin number 3 is output. Pin number 4 and 5 is the input of this AND gate and pin number 6 is the output. Pin number 13 and 12 is the input of AND gate and pin number 11 is the output. Pin number 9 and 10 is the input of this AND gate and pin number 8 is the output. The another IC is IC7402. This IC is NOR gate IC. This IC also consists of 4 NOR gate. This IC is 40 pin IC. Pin number 7 is ground. Pin number 14 is supply pin. Pin number 1 and 2. Pin number 2 and 3 are the input of this OR gate and 1 is the output. Pin number 5 and 6 are the input of this IC and pin number 4 is the output. Pin number 9 and 8 is the input of this NOR gate and pin number 10 is the output. Pin number 11, pin number 12 is the input and pin number 13 is the output of this NOR gate. In pin configuration of IC 7408, 7402 and 7404 is shown in the given below diagram. IC 7404. This IC is NOT gate, means hex inverter IC. This IC has 14 pin IC. Pin number 7 is ground, pin number 14 is the supply pin. Pin number 1 is the input of this NOT gate and pin number 2 is the output. Pin number 3 is the input of another NOT gate and pin number 4 is the output. Pin number 5 is the input of this NOT gate and pin number 6 is the output. Pin number 13 is the input and pin number 12 is the output of NOR gate. Pin number 11 is the input and pin number 10 is the output. Pin number 9 is the input of this NOT gate and pin number 8 is the output of this NOT gate. Theory regarding this experiment is Demorgans first theorem. The complement of logical sum equal the logical product of the complement. Logical equation for Demorgans first theorem is complement of A plus B. Complement of A plus B is equal to complement A into complement B. Proof: when A is equal to 0 and B is equal to 0. Left hand side of this logical equation is complement of A plus B is equal to complement of 0 plus 0, and that is complement 0, and the output is 1. Right hand side, complement of A into complement B is equal to complement 0 into complement 0 is equal to 1 into 1, and that is equal to 1, means left hand side is equal to right hand side. This is for first case. And the second case, when A is equal to 0 and B is equal to 1, left hand side is equal to complement 0 plus 1 is equal to complement 1, and that is equal to 0. Similarly, right hand side, complement 0 into complement 1, and that is equal to 1. Complement of 0 is 1 and complement of 1 is 0, means 1 into 0 is equal to 0, means left hand side is equal to right hand side. Case third, in condition third, when A is equal to 1 and B is equal to 0, then left hand side is equal to complement 1 plus 0, and that is equal to complement 1 plus 0 is equal to complement 1, and complement of 1 is equal to 0. Similarly, right hand side, complement 1 into complement 0, and that is equal to complement of 1 is 0 and complement of 0 is 1, means 0 into 1 is equal to 0. In similar way, when in fourth condition, when A is equal to 1 and B is equal to 1, then left hand side is equal to complement of A plus 1. Left hand side, complement 1 plus 1, and that is equal to complement 1, and complement of 1 is equal to 0. Similarly, right hand side, complement 1 into complement 1, and that is equal to complement of 1 is equal to 0 and complement of 1 is equal to 0, means 0 into 0 is equal to 0. In this way, we prove the Demorgans first theorem. Left hand side is equal to right hand side in the fourth condition. Logic equation, complement of A plus B is equal to complement A into complement B. Then Demorgans second theorem. Demorgans second theorem states that the complement of logic product equal equals the logic sum of the complements. Logical equation for Demorgan's theorem, second theorem, is equal to complement of A into B is equal to A complement plus B complement. Proof. First condition, when A is equal to 0 and B is equal to 0. Left hand side, complement of A into B, that is equal to complement 0 into 0 is equal to complement 0, and complement of 0 is equal to 1. Similarly, right hand side, complement A plus complement B. Complement A plus complement B is equal to complement 0 plus complement 0, and that is equal to complement 0 is equal to 1, complement of another 0 is equal to 1, is 1 plus 1, and that is equal to 1. So, left hand side is equal to right hand side. Similarly, second case, when A is equal to 0 and B is equal to 1, left hand side is equal to complement 0 into 1, and that is equal to complement 0, and complement of 0 is equal to 1. Similarly, right hand side, complement 0 plus complement 1, then that is equal to complement 0 is equal to 1 plus complement 1 is equal to 0, and 1 plus 0 is equal to 1. Left hand side is equal to right hand side. Third condition, when A is equal to 1 and B is equal to 0, left hand side is equal to complement 1 into 0, and that is equal to complement 0 into 1. That is equal to 1. Right hand side, complement 1 plus complement 0 is equal to complement 1 is equal to 0, and plus complement 0 is equal to 1, means 0 plus 1, and that is equal to 1. So, left hand side is equal to right hand side. Similarly, in fourth condition, when A is equal to 1 and B is equal to 1, left hand side is equal to complement of 1 into 1 is equal to complement 1, and that is equal to 0. Similarly, right hand side, complement 1 plus complement 1, that is equal to complement 1 is equal to 0 plus 0, and that is equal to 0 plus 0 is equal to 0, means left hand side is equal to right hand side. We prove De Morgan's second theorem. The circuit diagram of De Morgan first theorem by using IC 7408 7402 is shown in the below diagram. Similarly, circuit diagram of De Morgan's second theorem by using IC 7408 7402 and 7404 is also shown in the below diagram. You have to connect this diagram on breadboard by using below IC. You have to construct it on breadboard. Procedure for this practical is: first, check all the pin of IC and identify given ICs. To prove De Morgan first and second theorem, connect all the circuit components as shown in the figure on breadboard by using given IC. Apply plus 5 volt DC supply to the circuit by using DC regulated power supply. Check output of various input possibilities shown in the observation table given below. Apply one or high input, connect input terminal to plus VCC, and for 0 or low input, connected input terminal to ground. On condition of LED represent output is high or 1, or off condition represent output is low or 0. Observation table for De Morgan first theorem and De Morgan second theorem is shown below. Conclusion of this experiment is: the complement of sum is equal to the product of the complement has been proved after verifying observation table. The complement of product is equal to the product of the complement has been proved after verifying observation table. There is some assignment for you. Please note down in your copy and show me later on. This question is important point of view of your examination, so please note it down. The first question is: state De Morgan first theorem. What are the types of logic gates? State De Morgan's second theorem. What is 1s complement? Draw the symbol of IC 7432, 7408 and 7404. What is the logic equation of De Morgan second theorem? Okay, thank you student. Meet you in next period. Thanks.